Good evening, engineer. My name is Steven Yanchatipan, and this is to explain about the homework that you have sent to us. And now I am going to explain a little bit the objectives. So we have to use Matlab to graphicate a different type of signals, and then we have to analyze the main characteristics about each signal. So the first one was this. The first one signal was this. Sinusoidal signal that the amplitude is going to be 2 and the frequency is going to be 10 Hertz, and that's going to show in a range of t equals 0 to 1. Now this is the graphic about the sinusoidal signal, and as you can see, this is the first period, second period, third period, and then period 1 by 1 to 10, and the range by 0 to 1. This is the amplitude, that the amplitude is going to be from 0 to 2, and from 0 in the negative territory to -2. And this is the graphic about this sinusoidal signal, and we have to do a little bit modifications and this part. So this is explained about the previous image, and now we have to modify. We have modified the some parameters that you have to teach that you have taught in our class. I change the amplitude to 3 and the frequency change to 20 Hertz as well. So this is the graphic, and as you can see, we can see the difference about this signal to compare in the other signal that is in the red and points red. To explain is a little bit interesting because the blue signal, that is the first period. In amplitude from 0 to 2. But I change the amplitude to 3, and the amplitude is going to be the from 0 to 3. Oh, sorry. No. And the interesting thing about this is the frequency is in the red signal, the frequency is 20. So the frequency is going to be more shorter. How can I explain? More thin in respect to the blue signal. So when we read in the time in this territory of the plane from 0 to 0.1, that is two periods about the red signal. And what's happened to the blue signal is just 1. That's the main difference that I found in this graphic. Now this is the answer. That's how affects this change in the frequency of the sinusoidal signal. And we're going to the exercise 2. The exercise 2 was an exponential decay signal, because we have the signal minus, and the alpha is going to be 2, and it's going to move in a range about 0 to 2. The graphic is here. It's going to have an amplitude from 0 to 1, and it's going to decay, and it's going to be till the infinite. The range was the 0 from 0 to 2, and that's the graphic. And as you can see, the graphic of the exponential signal, where the amplitude is 1, because this is the operation where it's going to do a 1, and the maximum number is 10 equals 0. it's going to the key. No matter effects that is going to be negative. And now I change a little bit this. With where alpha is going, now it's going equal minus 0.5, where the new equation is this, new operation is this, and this is the graphic with the difference. Now this is the main graphic, and this is the graphic of modification. As you can see, the main graphic is in blue, and the second graphic, or the modification graphic, is going to be in a blue and red points. But how happens, or what happens to this graphic? Alpha is less in an exponential signal. The decay is going to be minus, and the signal is going to be minus more quietly with the time. It's going to fall more soft. As you can see, blue signal is more down than the red point signal. And we are going to Matlab a little bit time, and this is the first one. As you can see, this is the main the first exercise, and this is the two exercise that I resolved. So this was the explanation about this homework. It's so interesting to see the difference about sinusoidal signals, exponential signals, to see the different modification that the planes or graphics show us to improve our knowledge. So thank you very much, and this is my script. With the code exercise 1 and then the code of exercise 2. Thank you.